We're going to talk about probability, which is the mathematics of chance. Let's start with some vocabulary. We've got several different terms and symbols that go along with the language of probability. First of all, probability is the percent chance that an event will occur. We can use it to make predictions about an expected outcome. The sample space is the list of all possible outcomes or events. P of A is how we read P parentheses A. P of A is the probability that event A will happen. And finally, the theoretical probability is a computation that uses the formula number of favorable outcomes over total outcomes. Here's an example. Let's say that we toss a single coin, heads on one side, tails on the other. What is the probability that you get tails? As we move through the language of probability, the sample space is the set of all outcomes. Here, it's the set of just heads and tails, the two possible outcomes. Next, let's find the probability of getting tails. There's one tail out of the two outcomes, so favorable out of total is 1 over 2, or 50%. The probability values range between 0% and 100%. 0% meaning that it's completely impossible for something to happen, and 100% meaning that it's entirely possible, that it's absolutely certain that something will happen. And then it ranges anywhere in between those values. So we can use between 0 and 100%. If we put it in decimal form or in fraction form, we can express those probabilities as numbers between 0 and 1. In order to find the theoretical probability, we need to be able to count up the favorable and total outcomes. In this example, instead of tossing one coin, we're going to toss 3 coins. You can also think of this as tossing a single coin 3 times. How many possible outcomes? Well, we could try listing all the heads and tails outcomes, or we can draw what we call a tree diagram. On the left, we have the outcomes for the first toss. In the middle of the tree diagram, we have the branches that come off of the first toss and branch into the possibilities heads and tails for the second toss. And then finally, we branch out even more with the third toss, getting heads or tails following each of the possibilities for the first 2 coins. If you take a look at the very last column here, these are our sample space outcomes. This is where the list comes in. So we've got 3 heads, we can follow these through, we've got 2 heads and a tail, and so on. It's much easier, though, to put this together in a multiplication. So over on the right, we're multiplying the outcomes for the first coin. There's going to be 2 of those, heads or tails. Outcomes for the second coin. Again, it's the same coin, so there's 2 of those, heads or tails. And same with the third coin. There are 2 outcomes for the third coin. So we end up with a product 2 times 2 times 2, which gives us the same 8 total outcomes. Here's another example of counting up possible outcomes. Let's say that you're putting together an outfit and you're choosing between 2 different pair of pants, 3 shirts, and 2 shoes. Now again, we could start to list all of these possible outcomes, or we could create a tree diagram. In this tree diagram, the person chooses, so we're branching off with the pants first. So we've got the blue pants or the black pants. And then we're matching those up in the next row down with the shirts, the white, the yellow, or the blue shirt. And then finally, in the last row down, we're matching those with either the black or the red shoes. So we end up with, if we count all of those up, we've got 2 white shirts, blue pants, 2 different shoes, right? So we end up, as we count all those up, we get 12. Or a little more simply, we can use the multiplication principle. Our total outfits, we use the options for the number of pants, the number of shirts, and the number of shoes. We've got two pants, 3 shirts, and 2 shoes, which gives us a total of 12 for the number of total outcomes. Let's put some theoretical probability examples together. Going back to the 3-coin toss. So we're tossing 3 coins. We already did this first question. How many possible outcomes are there? There are 8, and we found that with the multiplication principle. Now let's go over to the right. What's the probability that we get all heads? As we take a look at the tree diagram, we can follow the heads options all the way through into the option, the favorable outcome of heads, heads, and heads. So we end up with 1 favorable outcome out of the 8, or 12.5%. Now let's do the probability of getting 2 heads. I've circled all of the favorable outcomes in that sample space. So that's going to be heads, heads, tails, heads, tails, heads, and tails, heads, heads. The sample space makes it really nice, so we can just go through and circle the favorable outcomes. That's going to give me 3 out of the 8, or 37.5% probability. In the next example, we're going to roll a die. Dice have 6 sides on them that are labeled with, are they called pixels? They're labeled with the little dots. We're going to roll a single die, and we want to answer the following. First of all, what are all the possible outcomes? Well, we can end up with, I think they're called pips. Anyway, we can end up with 1, 2, 3, 4, 5, or 6, which gives us 6 possible outcomes. In number 2, I want to find the probability of rolling a 1, a 2, a 3, or a 4. This gives me 4 favorable outcomes. 4 out of the 6 total. I can reduce that to 2/3, or 66.7%. Next, the probability of getting an even number. Well, the even numbers on this dice are the 2, the 4, and the 6. There are 3 of those, so 3 favorable outcomes out of the 6, giving me a 1/2 or 50% chance for an even number. Finally, number 4, probability of rolling a 7. Well, there is not a 7 on this dice, so that gives me 0 favorable outcomes out of 6, or 0% chance, because that is just not possible. Now let's look at some probabilities with cards. Here are all of the cards in a 52 card deck. If you're not familiar with a deck of cards, you're going to want to at least know the basics so you can answer some probability questions for examples with cards. There are 4 suits. In this diagram, the suits are listed in the rows. Spades are across the top, and then all the diamonds. Oh, then all the hearts, then the diamonds, then the clubs. There are 13 cards in each suit. 52 cards total. You'll notice that half of the cards are red and half of the cards are black. There are also 12 face cards. So the last 3 columns have the jacks, the queens, and the kings. And there are 4 of each. So here's an example. Let's say that we just draw a single card. 1 card at random from a deck of cards. Find the following. What's the probability of getting a red card? Again, we're looking for the number of favorable outcomes out of total. Well, half the deck. So we've got 26 favorable out of 52 total cards, 1/2 or 50%. Next one is the probability of getting a queen. This gives me 4 favorable outcomes. So I end up with 4 out of the 52. That reduces to 1/13 or 7.7%. Finally, the probability of an ace or a king. So that means that I would be happy with, so a favorable outcome would include any of the 4 aces or any of the 4 kings. That's going to be 8 altogether. 8 out of the 52, or 15.4%. We can also look at relative frequency probabilities. Relative frequency probabilities are based on using past data and not the theoretical probability formula. So we're using past data or results to come up with our probability. So in this example, Emily usually misses 1 day out of 5 each week. What is the probability that she'll miss class today? Well, if we use the data that we had for her in the past, it would be 1 out of 5 or 20%. We call this, even though it's in a fraction and it looks like a theoretical probability, we call this a relative frequency probability because instead of being based on favorable out of total, it's being based on past data. Here's another example of a relative frequency probability. We're also going to look at a subjective probability. In this example, a survey was taken of 200 high school seniors. It turns out that 150 of them reported that they'll be attending college in the fall. We want to find the probability that a high school senior chosen at random will be going to college in the fall. I'm going to use this data, the results from the survey, so it should be 150 out of 200, or 75%. This is an example of a relative frequency probability because we based this on the results of that survey. In question 2, we asked a high school senior what are the chances that he will be attending college. He answered 90%. This probability we call a subjective probability because it's based on his opinion or his best guess at what the chance might be. Let's take a look at all 3 of these types of probabilities together. First, we have the theoretical probability, where we were counting the number of favorable outcomes and dividing those by the total number of outcomes. This computes the expected chance of an event happening. For the relative frequency probability, we compute the probability based on data or results. Results could be from an experiment or a survey. And then finally, subjective probability is a probability based on an opinion or a guess. You are ready to practice and apply what you've learned. There's a lot that goes into probability, but with a few of the basics, you're ready to go.